Alright, so in this video, we're going to be looking at setting up our moment arrows. I got to thinking that we need to do a little bit more drawing before we're ready to do calculations. And I know we said originally we would be ready for calculations in this video. Got to get these arrows figured out because I'm going to be needing this to report results. Alright, so as you recall, go through and let's change my color. Go back to here. Alright, is that if I have say a beam that looks something kind of like this. If you recall, a moment is something that causes a rotational effect. It's actually the moment diagram that we're looking to draw of all of those effects everywhere throughout the beam. But let's say I have a point here in the middle of the beam. We would draw that as something that looks like that, and that would be my M, the moment. And so we need a representation to be able to draw that moment arrow, and it's a little different. We've drawn arrows before. We've done an upward and a downward arrow when we were dealing with our point loads and our distributed loads, but this guy's a little different. So there's a little bit more math that's got to go into being able to draw that. All right. So now what we can do is kind of think about, well, how do we represent this? And so the first one that we have to look at is, the direction. All right. Are we doing clockwise or are we doing counterclockwise? For 2D, that's the case. When we get to 3D, this is going to become a whole lot more complex. But again, we're just kind of doing the basics, two-dimensional, kind of getting ourselves set there. So that's our clockwise, counterclockwise for our direction. We need to know where are my start point and my end of the arc. Start of our arc. Okay. Where does it starts up here and then it ends down there? Where are those points located? Okay, and then the other one is where is this center point? Right, and that kind of gets us those are the factors that we have to have, and those will all go into how we draw the arc. The clockwise, counterclockwise will be very important in the actual load when we go and create that, probably in the next video. To be able to, is it a negative moment? Is it a positive moment? That will be dictated by this sign, right? So let's think about the geometry of drawing this circular arrow. So we've already said we're going to use an arc, okay, and more specifically an arc segment to draw that circular part, and then I'll draw the arrowhead off of that as well, because we got the arrowhead and the dimensions, and we know how to draw an arrowhead, but there are some issues that come into depending on my start points, actually. So we're going to keep it fairly simple, the old KISS method, keep it simple, stupid method, right? Okay, so let's think about what we have here. So I'm going to draw just kind of a grid on what I think we're going to do for now. And again, this is all subject to change as I get into it and decide that we don't like how something is. Okay, so the first point that we need is our center point. We're going to call that as point C there. Okay, and we've just got an arbitrary, here's a horizontal, and here's a vertical there. Okay, now, for us, what we're going to do is we could have, whoops, what did I do? Let's try that again. Is we can presume that we're going to have a starting point on an arc and an end point on the arc. For our case, I'm going to set it so that the start point is going to be 90 degrees from the horizontal. Okay, and it's going to be a minus 90 degrees if I go clockwise. This was counterclockwise, okay, which makes this guy also 270 degrees counterclockwise if I choose to go that. And that's kind of our right-hand convention. The negative is clockwise. Now, again, we talk about sign conventions and all this in our static series. So if you need some help, go take a look at the moment vectors definition video, and that will help explain that for you. I encourage you to watch that if you're interested. But for now, we just need to know how do I get the points, and we'll figure all that out. So this will be my start point, okay, and this will be my end point. And what we're going to do is I'm going to change the color here a little bit. Let's change it to green, okay, and we're going to draw this guy with the green arrow coming over to there, and that would be the arc that you saw for. Okay, so now one of the other factors that we need to be able to do this is, now by doing an arc, I can actually have two different radiuses. We're going to draw it as a circle for now, all right, which means that the line that goes up to here We're going to call that as our radius. That will get us that one. And then this guy is centered at the center, and it basically sweeps that arc from 90 degrees to 270. Okay, now we're gonna start at the start point, end at the end, and we're gonna draw it in a counterclockwise direction. That will get me this arc, this green arc that we wanted. If I drew it in the opposite order, started at the end and ended it at the SP, we would actually get a line that kind of came over and went the other side, and that we don't want that. We want to be consistent in what we're doing. All right, so let's see if I can. They're going to let me undo all my little green dots. There we go. Okay, so that's kind of what we're looking at doing. Okay, the other piece of the puzzle that we have to look at on this, and let's go change, say, to red, okay, has to do with the moment being clockwise or counterclockwise. So I could have an arrowhead that's here, okay, and that would be my clockwise moment, or I could have an arrowhead here, that would be my counterclockwise. And you can see each one is acting at a different point. Clockwise acts at the starting point, counterclockwise acts at the ending point. So we're going to have something that captures that direction as we start to kind of look at it. And again, we're going to specifically set it so that it goes from 90 to 270 as our starting point to locate. Kind of a polar coordinates kind of problem on there. Okay, now if we want to get into something a little bit more generic, and this is the way we're going to write this function so that I can change this on the fly, so it's a little bit more interesting. Okay, let's get our grid set up here, and maybe instead I want to go from here to, well, really even here. Okay, and this is still my center point, or my point where the moment is being applied to the diagram. Okay. And so if we do this, maybe this thing comes up and comes around. I am terrible at drawing arcs. Then maybe it does something kind of like this. It comes back, and so this is my start point, and this is my end point, or something kind of like that. All right, well, all we have to do now, change our color a little bit again, just to kind of get us some references. That we could do a line from the center through my start point. Okay, and we could call that, say, as some value alpha 1, an angle. Okay, now again, we do want to make sure that we do everything in radians. We'll be taking advantage of the pi constant in the math table. That will get us there. And then the other one would be, how do I locate this point? But with a little bit of trig and a little bit of polar conversion, we can get the locations of these points, which is what we're after. Okay, now this one, let's see, let's get rid of that. Give myself a little bit more room, that we can come in and, maybe this is, alpha 2, my end angle, if you will. And that will kind of get us to that one. And so if I know those two angles, I can figure out how to draw this, again. Okay, that's still my radius there. Okay, we're still going to draw it as a constant shape, a circle, and that will help us to be able to draw the arc. So we're going to take advantage of, what we call as an arc segment. This is the key in C# to be able to do this. We're going to draw it as an arc segment, and it's not quite as simple as just drawing a line. We've got to come up with, a path geometry and a path figure, and then put all the parts together. And thank goodness for Stack Overflow, because I've never done that before. But I know how to do it now, and it works, and we're going to kind of work on that. So with that being said, the only other piece that we have to work on then has to do with then drawing the arrowheads. And do you see the problem that we have when we start doing this? There are my arrowheads. What happens is that the line of the arrow is actually perpendicular to that line that goes through here. We're going to have to turn it to work on so that it's, when it was up in the first case that we're going to do, it's always horizontal or it's always vertical. It's very easy. But now that angle is going to change, and it's going to change all the points associated with the arrow. Okay. For now, we're going to punt on that part. We're just going to draw it, do the horizontal, vertical, like what we're doing here, and then we'll add some more logic if we need to later on. But we just want to get kind of a basic functionality whereby I can pass it the data and it can figure out how to draw itself on there as part of our drawing helper. So everything we're doing is in the drawing helpers on that. But that will be a challenge of, well, how do you define, if I draw this in through here, well, there's my line. Well, okay, it's perpendicular to the red line, and there's some other math that has to happen. It's doable, but again, we're trying to keep it just fairly simple for now, just get a representation on the board that looks, and then we'll work on cleaning up the geometry from there. So anyway, that's kind of a general sense of where we're going. So with that being said, I think we should jump into Visual Studio Code and see what we can do. So alrighty, we'll see you there. Alright, so here we are back in the code. And at the conclusion of the last video, we went in and we added a few features. I did a little bit of refactoring, and so I thought I would show you kind of where we're at and some features. I added a couple of little items just to kind of clean up the drawing and make it a little cleaner and easier to see. So we'll go ahead and get ourselves running here. And so you can see that this is kind of where we're at with our beam. Again, the red line is still the beam. And then we've got it set up so that, and I created some extra test cases just to kind of make it more readable and so that I could test more boundary cases for what we have happening. But again, the vertical green lines, those were our critical points that we found and the algorithm that we had for that. And if you remember in the code that we had a lot of repetition of code in finding those critical points. Okay. A couple of other things that I did is I resized our nodes, and I think I did that in the last video. I've made point loads a little bit more visible by adding a thickness to their arrow sizes. And then I've also, the boundary of, say, a distributed load, I've made it a little darker so that it's, once again, a little bit more visible. I have moved the roller support down a little bit. And then the other thing that I've noticed that you'll notice is I've also added some numbering to this so that I would know what number it is reporting for different things. So you can see my nodes are represented with numbers. Okay, and in this case, it was 0, 1, 2, 3, 4. Remember, we created these out of order intentionally to make sure that we could test the sorting algorithm. So those nodes are encased in circles. And again, the nodes are a little bit more visible. You can see I've added nodes at the support locations. I mean, they were always there, but the symbol for it is now included. All right, and then for my members, I've gone in and I've actually included these numbers, which are currently in green. Again, all this may change. And just to distinguish them from nodes, my usual convention is I like to draw those things inside of boxes. So I made kind of a crude little box, and then I put the member number in here. Okay, and hopefully if we do things right, none of this ever replicates as far as we don't repeat numbers, because again, they're all inheriting from that iDrawable item in which everything gets a unique static ID number. And then there's some that are skipped, and then those are based off of having made some intermediate nodes in between. So like there would be a node for a critical point here. There's a node for a critical point here, as well as on the other ones. And that's why you see it kind of jump from 5 to 7 to 9 to 11. And so there's some others that are showing up there. So that gets us kind of caught up on that. The other thing that we did is in mainwindow.cs, we went in, and so I extracted, since we're constantly looking in lists to find nodes, and we had a lot of repeated code that was happening. I extracted the search function to a new private function that I'm calling find node in list. It takes a point X, a point Y, well, a double, the coordinate X, the coordinate Y, and then a list of iDrawing objects that I call as L. Okay. And so what we'll look at, and now that I look at that, this isn't totally correct. So we're going to scrap that and we'll come back around. All right, yeah, I just noticed that in my process of copying code, and the reason that it still worked was that I'm passing in a list that I'm calling as L, and I had forgotten to change that guy. Okay, so that's the L. That's the list that we're passing in. So it's searching, in this case, for nodes in this list. And so that's why we got to be kind of careful, because again, it is an iDrawing objects interface item that VM node inherits from. And so now I'm looking for these nodes in L, and we should be able to work that. Okay, and then so what will happen is that it's basically checking that if it finds a node. If it finds a node, it returns the node. If it doesn't find a node anywhere in that list that has coordinates X and Y, then it returns null. All right, and so then when I go down to our list critical points, somewhere in here, you can see that this is now a whole lot more condensed. Okay, and so, we go through our process for concentrated forces. The first part of this is still all the same. We do our supports, we do our leftmost, rightmost, and then we do our forces and moments. And so if we look at our forces, you can see that now, instead of doing all that searching, I'm now just doing a find node in list. Okay, to see if it already exists in the node list, in which case I know that it's possible that the node is already there. And then if the node is in the nodes list, okay, then I check if it is located in the critical list. And again, I call this guy the find node in list, and this time I pass it our list value that was being added, that was being built off of support conditions. We were building this list here, and so that's what's being passed into the find node list. And then, of course, if there's no match, then I add it. Okay. Otherwise, if it returns a null when it searches the nodes list, then I know that I've got to create it because it's not possible for it to calculate. And then I run it again. Okay. And it's kind of, again, a little bit of repeat happening here as well. Okay. And so we're looking to find a node in list. In fact, okay, so the first time I do it, I'm checking the nodes list, and now I'm checking the list that I built. And again, just checking to make sure that we hadn't intermediately made a point at that location as well. So that equal node, and then of course, if it's not matching, then I add it. Otherwise, we're good. And so that condenses this down quite a bit. We had a lot of code that was happening on that. And then I do the same thing for the distributed forces, kind of the same basic process. And so we've got kind of this utility function for searching based off of an X and a Y and a list of iDrawable objects, whether or not a point with those two X and Y values exists. That's the whole point of what we did. So that's what we were looking at doing there. Over in, I think it was in my DrawingHelpers, we kind of went in and I added some information to our draw arrow function, mainly that I can now, if we come over and look, that I now have a head length, a shaft length, and then I've incorporated this thickness value, okay, that basically dictates how thick the arrow is when it gets drawn, and so that's what we're adding here. And so you can see that now I'm using that, and that's what's allowing me to draw the up arrow and the down arrow, of course. The draw arrow itself, I'm also passing it into the general draw arrow function here, and we are, again, kind of the same game that we were playing, arrow down, arrow up, and then passing through so that it knows how to draw it. I did go in and add, instead of just drawing an artificial circle or something like I had before, now I'm just going to throw an exception. That if I try to pass it a right arrow or left arrow, it doesn't know how to do it. And there'll be a lot more that gets added into this as we go. But again, we're just trying to get it up and running for those. Let's see. So for the other one had to do with, kind of where to draw text. Okay. And you can see that I've added an enum for a position of a text so that I can draw text above or text below, pretty much an object, and it offsets that. So if I go, where are all those at? Yeah, so we've extracted out in our beam a function that draws a beam label. So the draw function now draws the line. So we're in the beam, draws the line for the beam, and then it draws the label. And I did it this way because eventually I can put a flag on this that says, hey, should we draw the label? So I can hide and turn those on and off. And now I've got the function to do that it just says, okay, just go, this is how I draw it. And it does a bunch of calculations, and then you can see that it offsets the Y position a certain amount. If the text is above, it subtracts it, which moves it up. If the text is below, it adds it, moves it down. And I kind of played with it. It's not great, and we may adjust that. And then again, if it falls through, and I try to do a text left, text right, now I'm just going to throw an exception and bomb out on that. Okay, and so that's how we kind of drew all that. And then that's what we were looking at being able to do. Okay, and then the same thing over in our VM node. We did kind of the same thing. That our draw function for the node is still a little bit more involved because I've got the supports that have to be drawn. Okay, so that does those. But then I actually draw the node label on this. Okay, and of course I draw the node itself by adding this line to all of the cases. And then I'm going to draw the node label in a similar fashion, text above, text below, those kind of things. So that gets you kind of caught up on some of the stuff that we did. It took a little bit of work to especially get that find node function working, but that's where we are at. And I think that gets us caught up there. So now what we want to do the rest of today and the rest of this video is I want to go in and add some more drawing items. I know we said we were going to do calculations, but I want to go ahead and get the moment arrows drawn, because if I start drawing support reactions, I'm going to need those anyway. So we're going to go in and kind of in our drawing helpers function over here, we have an arrow up, an arrow right, arrow down, arrow left. Okay, I'm going to add to an arrow directions on here. Oops. We're going to do an arrow clockwise, and that's going to be a 4. And then an arrow counterclockwise will be a 5. And that will allow us, so what we're going to try to do is we're going to try to draw basically for the moments. And what I'm going to do on this is, we can play with this, but I'm just going to go for a 180-degree arc with an arrowhead on the end of it. And we'll just kind of see, we'll play with that a little bit and kind of see what we have here. All right, so first thing we want to do is we're going to play this kind of draw arrow this way. Okay, so I'm going to copy this guy down. Okay, and what we want to do is we want to draw arrow. Oops. Oh, come back here. So I'll do one for counterclockwise, get my canvas back in there. So that gets us that. Okay. And then lots of draws a circular arrow in a counterclockwise orientation. And that will get us there. And the way that we're going to do that is we need to draw the circular arc. Okay, and then we need to draw the arrowhead, something that looks kind of like that. And a lot of our information will still be the same. We are not going to need, let's see, hold on. This is the one that we don't need. That will get us that one. Okay, and so what we want to do is now, so again, another function that we need to add. We're drawing arrows, we're drawing text, we're drawing lines. I've come up with a draw circular arc function. And you can see that I pass it it receives a bunch of parameters, receives our canvas, it receives the center point of the arc, which is my X and my Y, and then I've arbitrarily set the default radius to 32. The start angle is going to be at positive 90 degrees or pi over 2 radians, and the end angle will be a negative 1 times that same value. So it'll be, kind of a semicircle going, starting at the top, going around to the bottom, and then it traverses down here. I set it to go in the clockwise direction. So if I run this, you can see what we're generating. There's the red line that we're wanting for our arc, our basic arc shape. Okay. Again, we can play with the appearance and those kind of things as we need to. Now, if we come in and we look at what we did, the code was very, very similar. All I've done is I've basically done some calculations to find the coordinates of those points based off of a center point and a radius, and of course, what I'm calling the start angle and the end angle from that center point. So if you imagine a line that goes from the center up to these points on the arc. So all I do is just like the first couple parts are all set the same. I create a path. I set so that there is no fill. I set so that my arc color is the stroke color, and I'll probably pass that in as a parameter on this function here in a second, or we'll tweak that a little bit. Thickness, I made it kind of thick so I can see it, 4.0. And then, of course, we do the canvas set left, set top to be able to set that upper corner of the shape. So all we do now is figure out what is our start angle and our end angle measured from the center to the point that I'm wanting on this. And that's all we're doing is, so we're kind of, basically, if I get some strange angle that's greater than 2 pi, what I'm going to do is I'm going to modulus that to 2 pi in order to get something between 0 and 2 pi for both SA and EA. And that will kind of keep us consistent on that. And that's all these two lines do. And then if I find out that my end angle is less than my SA angle, my start angle, then I switch them so that I get the little bitty piece in between. Otherwise, I'm going to calculate the difference in the angles. Okay. And then from that, now I go do what we were doing before. We create our path geometry, we create our path figure, and then I define my arc segment, for those kind of things. Let me see one thing, and I don't need all those parameters on this. Yeah, because we're gonna override all these. There's too many things happening right here. I'm just gonna do just the default constructor for the arc segment. Okay, and then I will build all the points that I needed in that function here. Sorry, so is it a large arc, meaning is it greater than 180 degrees? That's the definition. That has to do with the way that it's going to draw. I just check that angle difference against pi. Okay, and then all our angles are done in radians. We're going to figure out the start point for the arc, so that's our path figure. Okay, we're going to do a point, and it's just going to be x plus the radius times the cosine of that angle, gets me the coordinate of that point where we're starting, and then y plus the radius times the sine of the angle gets me the y coordinate. And then I do the same thing for the end here. Okay, and so if we look at, oops, let's see. Then we're going to set our size. I'm just going to set the size as a box that is of radius and radius. Okay, and then our sweep direction, we're going to draw this thing in a clockwise direction. Okay, now our variable for clockwise, counterclockwise will dictate which end gets the head when we get to that point. Okay, and so then we're going to add our segments to the figure, and then we're going to add the figure to the graph, and then we're going to add the geometry, the path geometry to our path data, and then we're going to add the path to our canvas. And that's pretty much gets us to what we have here. So that's good. So that gets us that one. Now we can go in and we can finish up the rest of this down here where we were playing with. So we drew our circular arc. Let's grab this guy. Because that was the basic helper, so this guy can go in here. Alright, and then I can make this, instead of pulling that particular point where we're drawing the arc, we're going to make this as an X. And we're going to make this as a Y, and that becomes my canvas C. And I can get that off of there. And then that gets us everything for the draw circular arc for the default. Now again, there are a bunch of other values that we can plug in. So again, we're drawing from up and down on the, on pi over 2 and negative pi over 2, and then drawing it clockwise at a radius of 32. Like I say, we can tweak that. Now we need to draw the arrowhead on this. Okay, and so what we're going to do is we are going to draw our arrowhead at, okay, if, let's see, arrow dot direction. I don't have my direction. Draw arrow counterclockwise. Oh, well, we're drawing it counterclockwise. In fact, draw. That will make this a draw circular arrow. Yeah, and then we will put in, got all of those parameters going in. Let's see. Fill stroke thickness. Where is, that's our arc. So we need brushes fill, brushes stroke, and then double thickness, and then we'll include our radius. That gets us all of that. All right. And our default thickness on this is going to be 4.0. So we'll make this thickness. We will make this guy fill. And then we'll make this guy stroke. Media brushes to media, not brushes, brush. And brush. There we go. And that will get us those. And then the rest of our math is all the same. So that gets us a generic draw circular arc. That gets us there. Okay, draw circular arc. So our fill is brushes dot transparent. Our stroke, brushes dot orange red. And then everything else we can just do as defaults. Let's see if that solves that problem. Go back to here. All right. Drawing helpers dot draw a circular arrow. We do need a direction. Fill, stroke, thickness. I need a direction. And then arrow directions dot. Where were we at? That was up here. That should be a no. Let's go counterclockwise for now. Arrow directions, direction equals arrow directions dot arrow counterclockwise. Gets me that one, and then we can do this one. Okay, does that get me? Ooh, what are this? Optional parameters. Let's see. Arrow directions. There's our direction. Also go arrow. All right, that gets us so we can set our direction, and then let's see. So we can do direction equals arrow directions dot clockwise question mark. If it is, we're going to do a sweep direction dot clockwise, or otherwise we'll do a sweep direction dot counterclockwise. And that will just be our kind of our logic check, fix our arrow the way that we're. Well, no, sweep direction, we're going to draw it always as, we don't need that. Don't need that. Sweep direction dot clockwise gives me that. And I don't need this here, because we're going to always draw it in that particular direction. All right. Let's see. Oh, still got an error. Draw a circular arrow. Let's do comma leftmost node dot x, leftmost node dot y, and then what else? Brushes dot transparent for the fill, brushes dot orange red For our stroke, our direction is arrow directions dot. Let's go counterclockwise. And then, why is it still wanting those? Those should be defaults. 4.0. Go back. You don't get a default. Let's see. All right, so we're going to move that part into where we called it. This just passes. It doesn't care what values it's doing. It just needs to know what they are. Gives me that. I can get rid of that. Okay, and then we can go back down here where we were drawing all of this. I can take all of it. Why is it? Equals default arrow shaft length. Yelling at me because I have my optionals out of order. And default arrow head length. And where is my thickness? Default arrow thickness. There we go. And then you. Let's see, I'm missing something. So canvas X, Y, fill, stroke, thickness, radius, start angle, end angle. There we go. Now with any luck, and I think I need an arrow directions here. Direction equals arrow directions dot counterclockwise. That's getting really long. What a crazy argument. Pull some of this down so we can see it all. Did that fix it? All right. And there's our arrow. So, and then of course we got to get the head on still. So let's go get that on there. All right. So that gets us a circular arc. That's correct. And then we're going to draw the arrowhead. And for that, I need to get the endpoint, which is going to be the same calculation as what we did for all of this. I need these two lines. So this is the start point. We're going to do double start X, start Y, double end X, end Y, and so our SX, pull that down, is going to be equal to Control V, start angle, and our SY is going to be equal to all of this stuff. That's, should be a start angle. Oh, capital T, lowercase. Got it. That gets me that. And then we'll set the ends. Index. End angle. Grab that, and then so that gets us those points. Don't need that anymore. And now we can draw our lines. Okay, so if direction equals arrow directions dot counterclockwise, we're going to use endpoint to draw the head. Okay, else use the start point to draw the head. All right, so let's try. We're going to draw a line onto the canvas at, that should be SX. SY. And again, this is fairly ugly, so we want to do let's see, start point SX minus head length SY minus head length. Stroke thickness, got that. And of course, I drew those in the wrong ones. SX minus head length. Control V. And then that's an E. Instead of doing the start point, I do the end points on these guys. E, E. let's see, what does that do? And that got us our red arrow in a clockwise direction. And I want the counterclockwise, which means I drew them. No, it doesn't. It's counterclockwise. That was not counterclockwise. Drawing these at the wrong. I flipped them. I get you this one. So switch those. Alright, so that gets us that arrow. And it's going in the right direction. And again, it really depends on the angle that we do, and there would have to be some more trig to get our arrows lined up and those kind of things. But for now, I'm okay with at least getting a representation of an arrow onto this. So let's go test that the other direction still works. And let's say we'll do this one at the rightmost node. Rightmost. Rightmost. And this time we'll just go clockwise. And you can see there's our clockwise arrow there. And like I say, we may play with the directions, we can play with the sizes and those kind of things. But again, we've got kind of a representation of what it thinks and what it knows it's trying to draw itself as. So that gets us our moment arrows. So we can use that for our support reactions. We can use that for applied moments, whatever the case may be. All right. So the last thing that we need to do, so that gets us the drawing part. Now we need to go into our loads and to be able to add our moments. And I know we're going a little bit long here. Let's see, where are we at on time? We are getting kind of long. So that gets us the drawing of it. I think we'll go ahead and stop the video there. And then in our next video, we'll actually draw or make a moment load case. And then we can physically do this. But we've got the helper to draw the arrows present and working. So I think that works okay. So that's what we have. We kind of got some arrows going on this thing. Getting our directions sorted. Works pretty good for me. So anyway, that's what we've got. I'll go back and I'll add some comments to the code and kind of clean that up a little bit. I don't see any need for a whole lot of refactoring. But for now, we are on our way again. So as always, thanks for coming out. You know, a little bit rough spot there. We'll edit this down and get it so it's clear and concise and you can figure out what you can follow along with what's going on. As always, leave us some comments down below. Let us know if you're enjoying this at all, kind of seeing what we're doing. I'm just kind of documenting something I was going to be working on anyway, so I thought I would share it with you guys. And we're on our way. We're within another video or two, we'll actually start calculations. I just wanted to get these arrows in there. You know, hit some low-hanging fruit on a Monday afternoon. So anyway, thanks for coming out. We'll see you guys next time. Happy engineering.